Alright, now we're going to learn an introduction to functions. And first of all, we need to define what a relation is. Now, a relation is any set of ordered pairs. So it could be like 1, 2, 1, 3, -5, 7, okay, blah, 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 blah. Any set of ordered pairs is a relation. Functions are special cases of relations where each x value is paired with exactly one y value. So this set of ordered pairs right here is not a function because the x value 1 is paired with both 2 and 3. Okay, the x value for a function can only be paired with one y value. So this could be a function alright, because every x value is paired with exactly one unique y value. Now we call the set of first coordinates, all the x values, the independent variable. Okay, that's what we plug into the function. And that set of all x values is called the domain. Okay, and notice it says all possible independent variables. So I'll talk about that in just a minute some more. Now the second coordinate is called the dependent variable. Its value depends on the value of the independent variable. We plug the independent variable into the function, we get the dependent variable out. Now with function notation, it can be a little confusing at first. So here's a basic definition. A function f in terms of the independent variable x is called f of x. That's not f times x. And f is like the label of the function. Okay, so we could say that f of x is 2x minus 3. That says take every x value, double it, and subtract 3. So, for example, f of 2 would be 2 times 2 minus 3, which is 1. F of negative 3 would be 2 times negative 3 minus 3, so that's negative 6 minus 3, which is negative 9. Now, you can label a function anything. Okay, so your independent variable can be anything. So I could have, say, v of t is negative 16t plus 7. There's my independent variable, which matches that right there. And this function is the v function in terms of t. So let's evaluate this function f equals x squared minus 2 for several different values of x. F of negative 1 will simply be negative 1 squared minus 2, which is 1 minus 2, which is negative 1. F of 2 is going to be 2 squared minus 2, which is 4 minus 2, which is 2. F of a is going to be a squared minus 2, and those aren't similar terms, so I leave it at that. F of x plus 1. This says take x plus 1 and plug it in for x in the f function. So f of x plus 1 is going to be quantity x plus 1 squared minus 2. Let's work that out. That's going to be x squared plus 2x plus 1 minus 2. And our final answer is x squared plus 2x minus 1. And finally, f of c plus f of negative 2. All right, f of c is going to be c squared minus 2. And we're going to add to that f of negative 2. Okay, that's negative 2 squared minus 2. So I have c squared minus 2 plus 4 minus 2, and end up with c squared. Now piecewise functions are where we put several different functions together, and depending on what we're plugging in, that will tell us which function to use. So let's take a look at this. This says that for any x value we plug in that's less than or equal to 5, we will use this function right here. And for any x value between negative 5 and 4, we're going to use this middle one. And finally, for any x value greater than 4, we'll use this third one. So let's evaluate this piecewise function for several values of x. F of 5. Okay, so 5 is bigger than 4, so we're going to use this one right here. So that's going to be 5 cubed minus 4 times 5. That's 125 minus 20, which is 105. Okay, f of negative 1. Well, I'll label that a there. F of negative 1. Okay, negative 1 is between negative 5 and 4, so we're going to use a middle one here. So that'll be 3 times negative 1 minus 2. That's negative 3 minus 2 is negative 5. Okay, how about f of negative 5? Well, if x is less than or equal to negative 5, we're going to use the first piece. So that one will be negative 5 squared minus negative 5 plus 1. That'll be 25 plus 5 plus 1, which is 31. And finally, f of 4. Well, if x equals 4, then we're going to use the middle one again. So for D, that's going to be 3 times 4 minus 2, which is 12 minus 2, which is 10. All right, let's talk about domain. Now remember earlier I said that the domain of a function is a set of all possible x values. So what that means is I only want to have values of x that return a real y value. Now the domain of any polynomial is all real numbers. And so if you have a function in the form of a x to the n plus b x to the n minus 1 plus c x to the n, there, c x to the n minus 2, blah, 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 all the way out to some constant where a, b, and c are all real numbers, you automatically know the domain is all real numbers. Okay? Well, when is the domain not all real numbers? We're going to be focused mostly in this course on two cases: rational functions and radical functions. So rational functions are going to be in the form of some function in the numerator divided by some function in the denominator. And what we have to watch out for is that g of x can never equal 0. So that's going to limit our domain there. With radical functions, it's going to be the square root of some function, or it could be the fourth root of some function. As long as it's an even root, we have to watch out because we cannot take the even root of a negative number. So we're going to make sure that f of x is always greater than or equal to 0 in those cases. So here's an example of a rational function. The function a in terms of t is t minus 2 divided by t squared minus 3t minus 10. So we have to make sure that t squared minus 3t minus 10 does not equal 0 because we cannot have 0 in the denominator. This will factor into t minus 5, t plus 2. That can't equal 0. So t minus 5 cannot equal 0, and t plus 2 cannot equal 0. So t cannot equal 5, and t cannot equal negative 2. That's your domain. It can be any real number except negative 2 and 5. Okay, so in interval notation, that would be negative infinity to negative 2, negative 2 to 5, and 5 to infinity. And now let's figure out the domain of this radical function. Well, we can't take the square root of a negative number, so we need to make sure that 4 minus x squared is greater than or equal to 0. That's the difference of two squares, so I'm going to factor it. And on a number line, okay, I've got a closed circle at negative 2 and a closed circle at 2. Both of those values will make the function equal to 0. We want the pieces that will make it greater than or equal to 0. So let's test a point to the left here, like negative 3. If I plug negative 3 in for x, this factor will be 2 plus 3, which is positive, and 2 minus 3, which is negative. A positive times a negative is negative. Well, we don't want anything less than negative 2 then. Let's pick a number between negative 2 and 2, like 0. So I plug in 0. 2 minus 0 is positive. 2 plus 0 is positive. Positive times a positive is positive. So we want to use that part right there because that will make the whole thing greater than 0. It'll be positive. Okay, and then finally, let's pick a point to the right of 2, like 3. So 2 minus 3 is negative, and 2 plus 3 is positive. A negative times a positive is a negative, so we do not want any values out there. So the domain of this function is greater than or equal to negative 2, less than or equal to 2. And finally, here's a quick way to figure out if a graph is a function or not. It's called the vertical line test. So if I take a vertical line and if I run it from left to right across my graph, and if I ever hit more then one intersection, like there and there and there, it is not a function. Okay? So function A is not a function. Whoop, come back here. There. Function B is a function. No matter where I run that vertical line, it only intersects it in one place. So this one is not a function. This one is a function. That's called the vertical line test.